Hello everybody, welcome back to the channel. Today we're going to be deriving an equation that is used when we're doing Newton's method, which tells you how to get from the x-coordinate that you're on in the step that you're doing in Newton's method to the next x-coordinate or the x-coordinate, of the next step. So if you don't know what Newton's method is, I encourage you to either watch my BC Calculus Applications of Derivatives Part 6, I believe it is, that talks about Newton's method. Or just look up a video online of what Newton's method is. And then once you've done that, you can come back here. I do explain this equation in that video, but the reason I'm making this video because I do not think I explained it to the best of my ability or explained it well. So I wanted to make a separate video explaining the equation again in a more intuitive way because I don't think I did it justice in that video. So if you don't know what Newton's method is, I encourage you to either watch that video or watch another video and come back once you do. And then we're going to figure out an equation that can tell you how to get from one step to the next step without having to draw tangent lines and all that nonsense, all right? So in Newton's method, right, if you'll recall, and I'll just quickly summarize it, all you're doing is picking a point, finding its tangent line, finding where the tangent line intersects the x-axis, and using that x-coordinate as your next step to repeat the process, all right? So to get from one x-coordinate in whatever step you're on to the next one, you draw the tangent line to that coordinate, find where it intersects the x-axis, and that's your new x-coordinate. All right. So using that kind of idea, we can figure out what your next x-coordinate will be. We'll label x sub 1 if we know what your current x-coordinate is, x sub n, because obviously x sub n plus 1 represents the next x-coordinate if the x-coordinate you're talking about is n, right? Here's n plus 1, the next one, here's n, the one we're on right now. Right? So we're going to derive, using that kind of intuition for the steps of Newton's method, we're going to derive an equation that tells us what the next x-coordinate will be if we know what our current x-coordinate is. All right. So let's say, my pad always times out for some reason. All right. So let's say we're dealing with some random function. All right. And we're at some x-coordinate x sub n. And we want to figure out what the x-coordinate of the next step will be. All right. Well, to do that, we have to draw the tangent line to the function at x sub n, all right? And I will note that the coordinates of that point are going to be x sub n, because that's the x-coordinate, and f of x sub n, whatever the function is at x sub n. And I'll say that this is just some random function y equals f of x, all right? So here we are, all right? If we want to find what the next x-coordinate is, if we're at an x-coordinate x sub n, we have to draw the tangent line to that point, figure out where that tangent line intersects the x-axis, and that's going to be the next x-coordinate we use. So the next logical step is to figure out what the equation for the tangent line is, all right? And using the point slope form of the tangent line, right, which we talked about in my part 6 of Applications of Derivatives series, the equation for the tangent line at this point, because we know what the coordinates are and we know what the derivative is going to be, the derivative at this point is f prime of x sub n, whatever that is. We can figure out the equation to the tangent line through that point because we have all the necessary components we need. It's going to be y minus f of x sub n equals the slope, which is the derivative, right, times x minus x sub n, minus our x-coordinate. This is the equation for the tangent line through that point in point-slope form, right? So we have the tangent line. Now if we want to find our next x-coordinate, we have to figure out when does this tangent line intersect the x-axis, and that occurs when y equals 0. So I'm going to replace y with 0. All right. So here we have an equation, right? And if we solve for x, that's going to tell us what the x-coordinate of our line is going to be when y equals 0, because we substituted y for 0. So our goal here is to solve for x, and we'll get x equals something, and that will tell us what our next x-coordinate is going to be as a function of all these other terms. And we'll get to that in just a second. All right. So to do this, we're going to have to do some algebra. All right. I'm going to expand this side. I'll get this side is equal to f prime of x sub n times x minus x sub n times, or let me write that another way, minus f prime of x sub n times x sub n. And this equals negative f of x sub n. All right. The next thing I'm going to do is I'm going to add this to both sides. All right. When I do that to this side, I'm going to get f prime of x sub n times x sub n minus f of x sub n equals f prime of x sub n times x. All right. I just added this to both sides. All right. When I add this to this side, you get a negative this plus a positive that gets to 0. So when I add this to this side, this becomes 0. And when I add this to this side, we get this on this side, obviously. So all we did here is add the same thing to both sides and do some algebra. All right. Next, I'm going to divide both sides of the equation by this. When I divide this side of the equation by this is going to go away. It's going to cancel. And when I divide this side of the equation by that, I'm going to have to divide this term by f prime of x sub n and this term by f prime of x sub n. All right. So let's go to another slide and rewrite what we have so far. All right. So you'll notice here we have f prime of x sub n times x sub n over f prime of x sub n minus f of x sub n over f prime of x sub n equals x. We have this equation, all right? Notice how in this term there's an f prime of x sub n on the top and an f prime of x sub n on the bottom, so we can cancel them out. So our final equation we get is that x equals x sub n minus f of x sub n divided by f prime of x sub n. That's a lot of x sub n's, I have to say, but hopefully the equation makes sense. All right. So now we figured out the x coordinate that our tangent line will be at when it intersects the x-axis. Using algebra, when we set y equal to 0 and we solve for x, that's going to tell us what the x-coordinate is when y equals 0, which means it's going to tell us what the x-coordinate is when our tangent line intersects the x-axis. And that's obviously in Newton's method, whatever that x-coordinate is the next x-coordinate we use, right? So I'm going to label this x sub n plus 1, right? Because the x-coordinate we find by finding the x-intercept of the tangent line is the next x-coordinate we use. So the x-coordinate I found with this equation, we can label it x sub n plus 1 because that's the next x-coordinate we're going to be using in Newton's method. So this equation tells you what the next x-coordinate you're going to be using is if you know what the x-coordinate you currently are at is, all right? And it tells you the next x-coordinate is the first x-coordinate minus the function at the first x-coordinate divided by the derivative at the first x-coordinate. And we just showed why that is true using some algebra, some tangent lines, and some linear knowledge of linear functions, right? So now if you're doing Newton's method, this equation makes things a lot easier because it tells you how to get to your next x-coordinate just by using a formula instead of having to draw the tangent line, figuring out where it intersects the x-axis, all that yada yada nonsense. This equation makes things easier because it just tells you how to get to the next x-coordinate just by plugging in values, just by plugging in three things, whatever the x-coordinate is of the point you're on, whatever the y-coordinate is of the point you're on, and whatever the derivative is there. So if you know those three things, you can get from one x-coordinate to the next x-coordinate, the next x-coordinate in Newton's method just using this equation. So it makes it a lot easier. Instead of having to draw things out and do a whole process, you can now just plug things into an equation and get to the next step just fine. So hopefully that explains this equation a lot better than I did in my previous video. That is the equation for Newton's method, or this is the equation for Newton's method that makes doing Newton's method a lot easier. I hope this helps, and I hope now you can go and solve Newton method problems a lot easier because you know why this equation works, and you can use it to find the next x-coordinate and just keep using it until you get to an x-coordinate that you are satisfied with that approximates the root of your function. I hope this helps, and I'll see you guys in the next video.